Hello, it's lesson 8.4. In this lesson, we're going to be doing exactly the same things we did in the last lesson, proving parallelograms, except these parallelograms are special parallelograms, and we call those special parallelograms rectangles and squares. All right? So, like I said last time, the things we do in class will also complement this lesson, okay? So there will be additional things you learn in class. But I'm going to just show you one of the many ways to prove on the coordinate plane that a quadrilateral is a rectangle and square. All right, let's get it kicked off. So there's two special properties we should review about a rectangle, right? There's only two. Diagonals are congruent and that all angles are congruent. And another way of saying is that, remember, is that all angles are 90 degrees. And I'm going to show you a different way to say that as well. There's another way. We could say that sides are perpendicular, right? If the sides are perpendicular, that's the same way as saying that all angles are going to be 90 degrees. So if you look at these two properties, diagonals are congruent. We can prove that using the distance formula, right? We just have to find the lengths of those diagonals. Now we could also show that sides are perpendicular by using the slope formula, right? We can use the slope formula for this one. Slope formula. So we can prove both properties of rectangle, but you only have to do one. You only got to do one. So today we're just going to focus on this guy, diagonals are congruent. That's how we're going to prove that this is a rectangle. So going back, oh, what? That is not what I wanted to do. Okay, if we go over here, so if you remember from last lesson, what we're going to do is first prove that it's a parallelogram by showing that opposite sides are parallel. Remember, that's just one option. And then we're going to show that our diagonals are congruent to each other. And that will prove that this is a rectangle. So let's show how to do that, okay? We're gonna show the math behind that right meow. And I challenge you to do this on your own without watching the video because I think you can figure it out. But if you need the video, I'll show you exactly how to do it. So, just like before, we're gonna prove a quadrilateral is a rectangle and it's given us the points. So the first step is to write those points down. So we have G at 1, 1, H at 5, 3. I at 4, 5, and J at 0, 3. Okay, so we got our nice looking rectangle. Now that guy looks definitely like a rectangle to me. I don't know about you. So this is G, H, I, J. Step 1, we're going to prove that it's a parallelogram. All right, so we're going to show the opposite sides are parallel. So first we're going to show JI is parallel to GH. JI is parallel to GH. All right, we're going to find those slopes. Then we're going to show that JG is parallel to IH. So JG is parallel to IH. All right. That's the goal here. So first, we're proving it's a parallelogram. We have to establish that first before we can go into the special properties. So once again, I say pause the video and do it on your own, or you could just watch as I do it. But I challenge you, just like, come on, we're in level 8 now. You should be like owning this stuff. It's all about you, like you're at that level. All right, so JI, let's find that slope. So I'm going to use the counting method. You can use slope formula if you want. I go up 2 over 1, 2, 3, 4. So my M1 is 2 over 4, which reduces to 1/2. Okay, that's slope number 1. M2. Let's find GH. So I go once again up 2 and then over 1, 2, 3, 4. Okay. Slope is the same. My slope is 1/2. All right. Now JG, we're going to go down to 1, 2, and then over 1. So M1 is going to be, if I go down 2, remember that's a negative slope, down 2 over 1, so that's just negative 2. So that's my slope for M1. And M2 IH, I go down 2 over 1, and so my slope again is negative 2. So we're going to show that these two, we've just shown that JI is parallel to GH. And then we're going to show that, we've just shown that JG is parallel to IH. All right, good, we've established a parallelogram. All right. Now, the next step we're going to do is establish that this is a rectangle by showing the diagonals are congruent. So here are my diagonals. We have GI and we have JH. All right, so we have GI and we have JH as our diagonals. So now that we've shown that's a parallelogram, we're going to show diagonals are congruent by using the distance formula. That will give us the length of our diagonals. So this is a little bit more involved, the distance formula, of course. So we're going to write down our points for G and I first. So G is 1, 1. I is 4, 5. We have our point. We'll just keep solving here. So D is equal to 3 squared plus 4 squared. Distance is equal to the square root of 25. The distance is equal to 5. All right, so we have our first side length. So we know the length of GI is 5. Let's try this for JH now. We're going to do the same process here. All right. So let's bring this down a little. So we're going to do JH over here. Same idea. We're going to write down the points for J and H. So my J is J is 0, 3, and my H is 5, 3. All right, so we're just going to find the length of JH. Write down our formula because we're good math students. X2 minus X1 squared plus Y2 minus Y1 squared. Now I want to say I am going a little fast here. All right, I know I'm rushing. What I'm doing is just plugging in points to these formulas. All right, and I know I'm going a little fast here, but just remember, all we're doing is taking these points, J and H, and we're plugging them into a formula. All right, so X2 is just 5. Okay. X1 is 0. Y2 is 3. Y1 is 3. So what we get here is 5 squared minus 0 squared, square root of 25, and that gives us 5 as well. So now we have proven that GI is congruent to JH. All right? And remember, I always kind of like to write what I've just proven. Okay, we've shown that these two these two diagonals are congruent because they both have a length of 5. All right, so now we've done all our math here, and there's tons of math. We've shown that the opposite sides are parallel. We've shown that the diagonals are congruent, and now, of course, we write our conclusion, and this is just like before. We just state the properties we used. Quadrilateral GHIJ is a rectangle because opposite sides are parallel and diagonals are congruent. Done and done. Now we're going to do the next proof, okay? We're going to do a square. I'm going to warn you, there's a lot to show here, okay? There's a lot of math. So to prove something is a square, you might remember this. The square actually has all the properties of all 3 special quadrilaterals. It has the parallelogram properties, it has the rhombus properties, and it has the rectangle properties. So what you have to do is prove one of each. You must prove one property from each. To show that it is a parallelogram, you got to prove it's a parallelogram using one of these, one of your parallelogram properties. You got to show it's a rhombus by using one of our rhombus properties, and you have to show it's a rectangle by showing one of the rectangle properties. And once you've shown that it has all 3 of these, you have proven it's a square because it therefore has all the properties. Okay, so you got to prove all 3. I know you're like, ugh. But you know what? It's actually not so bad. So what I'd like you to do is actually this. Instead of having me go through proving all of these things, what I'd like you to do is do the following. I'm going to tell you what to set up, and then you do the math and check to see that you got it right. So the first thing, we're going to prove the quadrilateral that's given, JKLM, is a square. The first thing we're going to do is going to plot our points. So come with me here. Let's plot our points first. So J is 2, -1. K is -1, -4. L is -4, -1. And M is -1, 2. All right. And sure enough, that looks like a square. But now we got to do the proof. So, step 1. All right, we're going to prove that this is a parallelogram. That's the first property we're going to do. Now, we've done this so many times at this point, I'm sure you could do it with your eyes closed. We're going to show that ML is parallel to KJ. So, ML and KJ. And then we're going to prove that LK is parallel to MJ. Okay, LK and MJ. All right. So we're going to find all these slopes to prove it's a parallelogram. Pause the video, do it yourself, okay? I don't want you to have to like sit here and watch me find all these slopes. See if you can find the slopes by yourself. So that's going to be our first step, proving it's a parallelogram. All right, pause the video now. If you've done your math correctly, you have counted out the sides, you found their slopes, and you've shown that the slope of ML and KJ are 1, so those two are parallel to each other, all right? And you've also shown that KL and MJ are parallel to each other because they have a slope of -1. Okay, the next step is to prove that it is a rhombus. Okay, so what we're going to do is show diagonals are perpendicular. All right, and watch this. It's going to be a little tricky, but I'll show you a little trick here. So if we go to LJ, that's our first diagonal. So we're going to write down LJ. That's our first diagonal. Our second diagonal is MK. Okay. So we got to find these slopes to show that they are perpendicular. Okay, that's just from the last lesson. So we're going to find the slopes again. M1, M2. Let's go for it. Now, if you found the slope of LJ, you'll see that the slope here, it's a horizontal line. So the slope is 0. The slope of our other line, though, MK, is undefined because it's a vertical line. But, little known fact, 0 and undefined, because it's a horizontal and vertical line, these are perpendicular. So if you have 0 and undefined, these are perpendicular. So LJ is perpendicular to MK. All right, so we've proven that it's a parallelogram. We got step 1 done. We've proven that it's a rhombus, so we've got our second step. And now finally we have to show that it has a property of a rectangle, and that's just what we learned how to do. So we're going to show the diagonals are congruent. So we're going to show that the length of MK and the length of LJ are congruent. Now, this is a little bit easier than normal because you don't have to use the distance formula. When it's just straight, you can just count the units. So that saves us some work. So we're just going to count the length of MK. That's 1, 2, 3, 4, 5, 6. So MK, the length here is MK is equal to 6. And LJ, let's count that. 1, 2, 3, 4, 5, 6. So LJ is also equal to 6. And sure enough, since these two diagonals have the same length, we now have proven that MK is congruent to LJ. All right, we've proven all the properties. We've proven that it's a parallelogram. We've proven that it's a rhombus, and we've proven that it is a rectangle. So now that we've shown that it has all three of these properties, we now know that it's a square. So we can finally write our conclusion. Quadrilateral GHIJ is a square because the first property we proved is that opposite sides are parallel. The second property we proved is that diagonals are perpendicular, so now we know it's a rhombus. And then finally, we proved that it is a rectangle because the diagonals are congruent. Done and done. All right, that's it, guys. Remember, next time you see Mr. Rodriguez, give him a kiss on the cheek. He likes those.